Okay, we're going to start looking at chapter 4, section 4, which is dealing with counting rules. The most basic counting rule we have is called the fundamental counting rule. Sometimes it's called the multiplication of choices, but more often than not, it's referred to as just your fundamental counting rule. So what that is, in a sequence of n events, so n, we're talking about any number of events, 2 events, 18 events, 2,000 events, in which your first event, or event 1, has k1 possibilities, and the second event has k2 possibilities, and the third one has k3, and so on and so on and so on. The total number of possibilities in that sequence is found by multiplying all those number of possibilities out. Okay, and that'll make a little bit more sense in a second. But just think of whatever your first event is, whatever that K1 is. K1 is how many different ways can you do that. Okay. K2 is how many different ways can you do the next event. K3 is how many ways can you do the next event. I'll give you a quick example. Applebee's or Ground Round sometimes. I think it's Applebee's is the one I think of off the top of my head. Has something like a pick 3, where you pick an appetizer, and then you pick an entree, and then you get to pick a dessert. Okay, so what I want you to think of that as, pen is really slow right now, as, that's not going to work. There. Okay, think of it as 3 different things. You have an appetizer, you have an entree, and you have a dessert. Those are really bad. So from the menu, they may say you can pick one of these 6 appetizers. Okay, so you have 6 choices to pick for an appetizer. And then pick from one of 10 entrees. And then you have these 4 desserts. So there are 6 ways that you can pick an appetizer, 10 ways that you can pick an entree, and 4 ways that you can pick a dessert. You figure that out by just multiplying these numbers. So we got 6 times, I'm going to do it this way, 6 times 10 is 60, 60 times 4 is there are 240 different ways that you could do a pick 3, if that's how many different options you have. The thing I want you to keep make note of, and maybe you want to write this down, is this fundamental counting rule only works when one of 2 things is true. When the order matters, or when each event is something distinctly different. Okay, for instance, like right here, an appetizer is distinctly different than an entree, and those are distinctly different than a dessert. If we were saying how many different ways could you pick somebody for first place, second place, and third place, that's where order matters, because first place is different than third place. Where it doesn't matter is if I came to class and I said, I'm picking 5 of you and I'm going to give you a trip to Hawaii. Okay, it doesn't matter if you're the first person picked, the 4th person picked, the 5th person picked, you get the same prize. Okay, so in a situation like that, this fundamental counting rule doesn't work like it's defined right here. If I said the first person I pick gets a trip to Hawaii, the second person I pick gets a trip to California, the third one gets a trip to Colorado, the 4th one gets a trip to Fargo, and the 5th one gets a trip down to the office, then order matters. And then this fundamental counting rule would apply. But when order doesn't matter, or when each selection is distinctly different, it doesn't work. Okay? All right. So here's another example. A paint manufacturer wishes to manufacture several different paints. And we have some different categories. You have a color, you have a type, texture, and then the use. How many different kinds of paint can be made if you select one color, one type, one texture, and one use? So think of this as how many different how many different categories are there? How many different things are you picking? And what I tell everybody to do is just start off with lines. Okay, how many different ways can you do it, or how many different things are you picking? You're picking 4 things, right? You're picking a color, a type, a texture, and a use. Okay, so that's why I'd say color, type, texture, use. Just write down 4 lines, right? So the first one is color, types, textures, uses. There are 7 colors, there are 2 types, there are 3 textures, and there are 2 uses. Multiply all those out, and you get 84 different ways to create a paint. If you have any questions on that, please write it down. This permutation, we're not going to worry about right now, so you don't even have to write it down right now. Okay? If you want to get ahead, that'll be tomorrow. One way of doing this usually is factorial. Factorial is a product of all positive numbers from 1 up to a number. Usually in your math class, it's presented to you as from that number down to 1. So if we say like 5 factorial, okay, 5 factorial is written 5 exclamation mark. The way you find that is you take 5 times 4 times 3 times 2 times 1. So 5 factorial is 20, 60, 120, 120. Okay. Now where this can be good for is, we have 5 people. How many different ways can we give them 5 different job titles? First person's president, second person's vice president, third person is secretary, fourth person is treasurer, and fifth person is public relations. Well, there's 5 people to pick for president. Then there's only 4 left for VP, 3 left for secretary, 2 left for treasurer, and then the final person is public relations. So it's not always that it's 5 factorial. It's not always that it's factorial, because sometimes we don't use all the people. But if you are using all the people, keep in mind that factorial. That factorial will come into play a lot more when we get into this permutation combination, but it can be used for the counting rule as well. Okay. I guess another example would be what if we have 20 people to pick from, and we need to fill president, vice president, secretary, treasurer, and public relations. You think, okay, we still have 5 blanks, right? 5 separate things to pick. How many different people could we pick for president? We could pick 20 of them. Now, if one of those persons is gone, how many people are left for vice president? 19. How many people are left for secretary? You have 18. How many people are left for treasurer? You have 17. And how many people are left for public relations? You have 16. And you multiply all those. And I don't know what that is off the top of my head, but it all depends on the situation. Here we have 20 people, we're filling 5 spots. Here we have 5 people, we're filling 5 spots. Okay? That's it for your video. Make sure you write down questions if you have any, and we will see you tomorrow in class.